Thank you. Thanks, Katie. And thanks everyone for joining the call today. So let me, we'll just start with the introduction. I mean, my name is Rakesh Gode, and I'm a DevOps lead here at Smart Data. Been with Smart Data for a little over 7 to 8 months now. Before that, I mean, I've been in the IT industry for almost 20 plus years now. And been through all those application development, database administration, worked on the SQL side. I mean, you name it. But last 4 to 5 years, I've been concentrating more into the cloud infrastructure and DevOps area. So today, basically, that's my background and professional experience wise. I have my LinkedIn account listed in my presentation over there. If need to connect with me, please feel free. And yeah, excited to talk about some infrastructure as a code today. Before that, I'll let Angeshwar also introduce himself. Angeshwar.
Yeah, thanks, Rakesh. Hi, guys. My name is Angeshwar Machraju. I've joined Smart Data in 2017. I've been here working with them on multiple areas. My background is in IT from the last 10 years almost. So I worked as a QA lead, automation, as well as in DevOps. And now I'm currently also working as a technical business analyst. So I've played multiple roles, and I've also given my LinkedIn profile. So I'm really excited to talk more about infrastructure as a code and the next steps. So we'll be covering a few of the topics. Rakesh, if we can just go to the next slide. So we will be talking more about infrastructure as a code and also what we are using like Terraform and what are the different tools that we are using and how we will be configuring the AWS infrastructure with Terraform and other cloud platforms as well. So the next things will be explained by Rakesh. Thanks.
Yep. Thanks, Andy. Let me. I'll be skipping between the screens here. Please bear with me. So I might. I got this screen reduced a little bit. I hope you can see it, right? I mean, still what's displayed here, or do you think I should be enlarging it? Maybe?
You can enlarge
I would probably enlarge it. It's a little hard to read from this.
Okay. It is because I'll be switching between. That's okay. I'll start from here. Then whenever needed, I'll just skip.
Yeah. Yep.
So,
just go back now.
Yeah. Okay. Good. So let's start with our topic today: infrastructure as a code, right? I mean, what infrastructure as a code is. As the name tells you, I mean, basically, we're trying to deploy some infrastructure, mainly virtual infrastructure, basically writing it as a program in a programming language, right? I mean, there are ways for us to deploy to provision infrastructure on Azure or AWS or Google, where you can directly go to the portal, create your resources as needed manually. That is definitely a good way. I mean, you can do that, works well, but the problem comes when you have a different environments, right? Like a dev, stage, or production. You want to basically, as a programmer or a developer or any IT team, I mean, we want to have basically environments be similar in nature. So doing that manually will add a lot of problems for us, right? I mean, you basically create one for dev manually, and if you just want to go ahead and create that for the production, then you need to remember each and everything, every configuration that needs to be done. So that's where the infrastructure as a code comes in handy. So I mean, it is basically an automating your infra, basically build the code and provide all the configuration that you need. Let's say if an app service you're deploying on the Azure, what kind of a configuration it needs, what properties it needs. All those things can be defined in infrastructure as a code, and then can be used in a basically pipeline method or some automated way to provision the same resources that on cloud instead of doing it in a manual way. So that's pretty much, I mean, that explains the infrastructure as a code kind of thing. So, but some of the benefits we can talk about when we talk about infrastructure code is like deployment. So basically, we are avoiding any manual provisioning interaction with the cloud providers. And also, it helps us recovery as well, in case if there is any issues in deployment or any let's say, I mean, for some reason we lose our environment or something. So having all the infrastructure written in the code, it helps us recover faster. Basically, we can bring up the entire system in the same way it was there before. So also, it'll help. It helps us collaborate changes as well because it's all in the code. Number of the team people in the team can review and comment on what's. If things are right or wrong, just the way we do it in the application review process. So even before we deploy anything on cloud, things can be reviewed. That's another big benefit over here, and always a consistency. I mean, we know since it's based off the code. I mean, every time we deploy some resources, it's always same. I mean, it won't change, right? I mean, with a manual, if you're doing it manually, we might miss something that we might have done it 2 days back. So those kind of things can be avoided, and since everything resides in the code, we can basically version control it. We can know who is making the changes, why the changes are made. It's just like any application development, things can be controlled, version controlled on the code. Or again, as I talked about, like visibility, it gives a visibility on. I mean, if we need to go find if you need to understand who made why the change has been made and who made it, kind of thing. So those kind of things also gives it helps in that way too. And also a reliability, reusability. It's a big thing with the infrastructure as a code, because all we have to do is, have the code written once, and the same code can be used to deploy for your dev environment or test staging or production environment. And the good thing is, since the code is the infrastructure is in the code, part of the code, some of the environments can be even built by developers, right? I mean, sometimes, we need a dev environment for which in a regular process, you will put up a request to the operations team, and they might have to go and set up environment that you need for your dev environment for development too, which is actually takes a very it's a time-consuming thing. So such kind of scenarios, can be basically done. The pipelines can be executed by anyone who has authority in the development team or some other team, and they can have the dev environment ready for them to start working. So it's so not waiting on another team for them to do it. So that's where it really helps. And also, as I said before, it works as a disaster recovery too. In case if something happens to some cloud, like Azure cloud or AWS cloud, and you lose all your environment. But the good thing is, if having everything in the code is just all we have to do is just go run the pipelines, and we have the environment back up the way it was. So those are some of the good benefits of having infrastructure as a code. But let me just reiterate that most of the times, I mean, like when we're talking about this, we are talking about just like a virtual environments. Either it could be cloud environment, or it could be like a environment on the VMware or Hyper-V. That's where we can use this infrastructure as a code. Physically, I mean, like if it's a physical server, this obviously we can't use any code to get that thing done. So yep. So that's a little bit overview of infrastructure as a code. I mean, like why, what it is, and why we need, why it's helpful. So moving on, just want to talk a little bit about little technical here. I'm like about like declarative versus imperative infrastructure as a code kind of thing. What's the difference? So infrastructure as a code, I mean, it can be used in both ways. One is imperative. Basically, imperative means like telling what to do, right? So the examples would be, I mean, AWS or Azure, they do provide a command line interface, which is called AWS CLI or Azure CLI. So in there, it is a quick way to go ahead and provision the resources. So here in example, if you see, we are like a provision two resources, one in AWS and one is Azure. And if you can see, it's pretty much it is basically a command, just telling, I mean, like this one is saying on AWS, go ahead and create the bucket with this bucket name. So we are basically instructing the computer to do this for me. Same way in Azure, saying, go ahead and create this key vault in this resource group and everything. So it works fine. Like it does the same thing what the infrastructure as a code, the other methods will do. But in the imperative way, it is just trying to create that. But in case, let's say if this key vault is already existing, there's no way for it to create the new one. It will just throw up an error saying, hey, the key vault is already exists. I have nothing to do here. So, but there's a ways to update as well. I mean, like you will have to use a separate command, like instead of AZ key vault create, there will be AZ key vault update command or something like that. So it's basically like just like one command at a time where things will take care of it. But in the declarative way, what we are doing is we're telling the machine what we want, right? So most of the infrastructure is code tools. For example, Terraform or CloudFormation or Azure Resource Manager. They use a declarative way, basically defining your resource, your properties, and everything. What it does in the background is, I mean, like here's an example, like a Terraform HCL example, where I'm trying to create a resource group called like RGSDS Lunch and Learn. I mean, like I'm providing the name here at a different location, but basically telling the system to, I want this resource group to be created, and it basically, what Terraform in the background does is it goes and checks on the Azure if it has a state file, right? I mean, Terraform works with a state file. It checks on the state file if resource group is already there or not. If it's there, well and good. I mean, like it will make any updates if we have added more tags here instead of resource type. And like if I added more tags saying, hey, name equal to lunch and learn or something like that. So the beauty of the declarative is, I mean, like it will just update that property and you're good to go. But and if it's not there, I mean, like it will create a new resource group. So that's the thing. I mean, like with the imperative, it basically just try to execute what you're telling it. I mean, like if it doesn't find, it fails. And the declarative way of doing it, it's always based on the code that we have written. I mean, it will either create or update. So yeah, that's a small thing I wanted to talk about before we get into more into the Terraform and Azure DevOps. So Yeah. And let's talk about a little bit of process flow. So in general, like for infrastructure as a code, the process flow, this is a very high level process flow. I won't say that this is what we do all the time, but mostly, I mean, like you'll see, it might sound similar to a lot of application development or kind of thing, right? So everything starts with the requirements. We start with the requirements. Once we get the requirements, I mean, the infrastructure, we design the infrastructure on, in this case, since we're talking about the cloud, we're talking about Azure and AWS, what all resources we need, what we need for that project kind of thing. So once the design is done, we go ahead and write the code. And this could be the CloudFormation, it could be in the like a Azure Resource Manager, or can be in the Terraform, or some other way. I mean, like but since we are talking about the infrastructure as code, I'll say like let's think that we are writing the code in Terraform or CloudFormation or Azure ARM. So once that's done, we deploy and test. That could be through the pipelines, which we'll go over after when we get into the demo kind of thing. So once deploy and test is done, then we look at like if infrastructure meets requirement or not. If it meets, well and good, go ahead and use it for the desired environment, that is like dev, stage, production, or any other environment that we want to. And then once this cycle is done, we go back again to the requirements, get more data, more requirements, and then start the process again. But here, if infrastructure does not require, does not meet requirement, then go back and to the design infrastructure whiteboard, and then rework on that the same way. So yeah, this is a general workflow of what we tried to follow. So moving on, we'll talk about a little bit of configuration, provisioning tools as well, right? And when we talk about infrastructure as a code, there are two kinds of provisioning that happens. One is configuration, and one is infrastructure. So obviously, configuration happens after the infrastructure provisioning tool, but for this lunch and learn, we are mainly focusing on infrastructure provisioning tools, not on the configuration. So in the configuration, some of those are like Chef, Puppet, Ansible. What this tools does is I mean, you can basically have a configuration file set which can be executed on infrastructure that is already defined, right? I mean, it can go to the Docker as well. I mean, I can you have a Docker image and you need something to be installed, or some configuration needs to be done. Those kind of things can be achieved by Chef, Puppet, or Ansible. Even on like let's say if it's a Windows system, you need an IaC setup on Windows. So IaC, I mean, like that can be done manually too. But if the configuration files are set in one of these methods, that can be used on multiple systems in the same way with the same configuration. So that's where the configuration tools help. And again, this is as infrastructure as a code, but more after the like deploying the infrastructure. So talking about that, like next, let's go to the infrastructure provisioning tools. And this is what our focus is today, because what infrastructure provisioning tools does is, as we discussed, I mean, it will create like a VMs on cloud, or VMware, or on the Hyper-Vs, right? That kind of infrastructure can be deployed. I mean, there won't be any configuration done with this. We're just deploying resources. So here we have like some of the 4 like well-used tools that we'll just go over with this. I mean, the first one is like a CloudFormation. Just wanted to talk about this. CloudFormation is AWS specific. So basically, AWS has their own like a tool which and which they use to create infrastructure on AWS. So the good thing about this is, I mean, like it works with the Amazon Web, like a AWS, but it won't. The problem is it won't work with any other infrastructure deployments. So if you have a multi-cloud environment, if you have AWS, Azure, then it won't work. I'm like the only way you can deploy. The only place that you can deploy with the CloudFormation is on the AWS, and basically, I mean, like a CloudFormation can be the configuration files in CloudFormation can be written in JSON or YAML. And similarly, if we look at the next one, it's Microsoft Azure Resource Manager. So again, Azure Resource Manager is same as CloudFormation, which is a deployment and management service for Azure. And ARMs use JSON files as where you can write your configuration files, and that those templates can be used to implement infrastructure on Azure. So both are similar. It's just like one work with Azure, one with the CloudFormation. I'll come to Terraform, but let me go to the Pulumi first. Pulumi is another infrastructure as a code tool. So this is something I've never worked on, but it does interest me a little bit. So I just wanted to talk a little bit about this. Pulumi also works just like Terraform, but the advantage with the Pulumi is, I mean, it supports multi-language. I mean, what that means is, I mean, infrastructure can be written in either Python or Go or .NET Core or Node.js, or I believe there might be more languages. As I said, I haven't worked with it, so I don't know. But so it does support like code to be written in different languages, which is good. But that we have a multi-language support. But the problem I see is, I mean, there's no common domain-specific language, right? I mean, like it based on what you want, and you use that particular code. So that's the main difference between Pulumi and Terraform. Coming to Terraform also supports multi-cloud environment. I mean, like both Pulumi and Terraform both can deploy or provision resources on Azure or GCP or AWS or even like a VMware like environment on premise as well. So that's good. Both can do that, but the biggest difference is the support of languages. So Terraform works specifically with their HCL configuration language. So I mean, there's no other language that it supports. So in a way, that's good because you're always working with one language, and that one language, HCL, can handle deployment of infrastructure on all the environments, so to the Amazon, to the Azure or Amazon or GCP or VMware kind of thing. So that's why, I mean, and also the good thing about Terraform is definitely it has more documentation, better documentation, bigger community. You get more help. So that's my take. Nothing. So that, and yeah, that's these are 4 tools. Just wanted to discuss about this. Just give an update. I mean, overview. Hope this helps on choosing what kind of tool that you would like to use. So going forward for this particular lunch and learn, we will be using Terraform, where basically because we want to show how the Terraform can be used to deploy to AWS as well as Azure. And okay. So why Terraform? So obviously, some of the reasons I already talked about. I mean, it is an open source infrastructure as a code tool created by HashiCorp, which can basically build, modify, and version infrastructure safely. And efficiently on different cloud platforms, right? I mean, like something that we just discussed about. So, and obviously, if you look at the benefits, it's a declarative approach. So, uh, uh, basically, Terraform works behind the scene. I mean, like it knows if the resource is already there, what it needs to do. And we'll go through that in the demo. I'll show you how these things work, and we can see the results as well. And definitely, we just discussed about uses one language. So that's a plus, at least in my view, because I mean, like, it, yeah, and obviously, like it helps multi-cloud infrastructure deployment, pretty much everything that we just talked about, and definitely reduces the development cost. Um, Code is reusable, right? I mean, like, so I mean, saves a lot of time for the organizations deploying the same thing manually again and again, compared to having infrastructure as a code in Terraform, which you can use it for multiple environments. So just have one code for have the like a code written for one environment, and that can be used for multiple environments. So obviously saves a lot of cost in provisioning cloud infrastructure, as well as I mean, like it saves a lot of time as well. And obviously, I mean, like it improves the consistency because everything is in the code. So consistency, there's less configuration drift, and yeah, some of the benefits on the Terraform will go. So now that like we have explained why Terraform and what are the benefits of it, I mean, let's look at some of the initial setups that we need. I mean, I'm going to talk here and I'll show you a little bit on the DevOps side. I mean, like as we talk about these setups, we are kind of like getting into a little bit on the demo side now. So the first thing we need to do is whenever we work with the Terraform, Terraform works off of a state file, and it needs a location or storage or some place where it can save its state file, right? So it could be either AWS bucket, it could be a Azure storage account, or it could be any like a storage place on the network or something. So most of the times, I mean, since we are working with the cloud here, I just mentioned two things about AWS bucket and AWS storage account. This one step, we have to do it manually, or if there is already an existing storage that can be used, that's well and good. But if an organization is starting with the Terraform just as a fresh, right? I mean, like you're just digging into the Terraform thing. So definitely one storage account needs to be created on the Azure side so let me just go ahead and show it to you on Azure. I'm just going here. So if you look at this, I mean, like I've created a storage account for Terraform state file. Within this, there are containers, and I have the container called Terraform. And this holds the Terraform state file. I mean, like basically what this file is, I mean, like it holds the complete configuration of your deployed environment on Azure or AWS or anything. So when we run the pipeline, when we execute the Terraform apply basically keeps the state. I mean, and if we go ahead and once once we deploy the resource, and if you go and make any change manually, that's not going. I mean, like that's going to differ from what's in TF state file. So it's a good practice. Once we deploy the resource using Terraform, always deploy to the Terraform. Do not do things manually. So they just wanted to highlight that. And let's go back to my PowerPoint. So that's storage. That's main storage is a must for Terraform. And once we do that, then one main thing. I mean, since we are using the Azure DevOps here, These are the steps for the Azure DevOps. It can be different for some other way of deploying. I mean, like you can use the Terraform Cloud as well to deploy resources, but we'll talk about that a little later. So one of the extensions that is must in the Azure DevOps is we need to install the Terraform extension, which I gave you. Sorry, where I gave the link over here. I mean, if you look at, I'm sorry. So yeah, so basically you just need to go to that link, install the extension of the DevOps that provides the Terraform task that is required for our pipeline to use. And then the next step is like service connection from Azure DevOps to cloud. So because we're working on the Azure DevOps, we need a connection between DevOps to the cloud, right, to the endpoint. So I'll show you for the Azure here. Angesh can show about the AWS when he gets into that. But typically, I mean, like once we go here with the Azure DevOps, we go to the project settings. And within the project settings, there will be service connections here. Service connections is the kind of thing, basically it sets up connection between DevOps and the third-party tools. I mean, like right now here, I set up a Lunch and Learn Azure connection. This is, I mean, like if you look at it, this is a Azure Resource Manager. Remember we talked about Azure Resource. So how DevOps does is, I mean, like Azure DevOps connects through the Azure Resource Manager to the Azure, and that gives the access to be able to create resources on Azure side. Similarly, I mean, if we want to create a new service connection, let's say for AWS, so all we do is click on the new service connection and AWS for Terraform. So AWS, this is the option that we need to select for AWS. And you can see there are like many more service connection options are here. It all depends upon what we are doing. Right now, because we are in the infrastructure, we are basically looking at the Azure Resource Manager or AWS. So the others can be used for the applications, the different connection types. And when we, so this is important. That needs to be done for our Terraform to work. And then the next thing is agent pool. So there are two ways for for us to set up agent pool. Agent pool is basically a system that when you run your pipeline, it needs a location where it can start checking out the code, build, push, deploy, and all this stuff. I mean, it could be like our own system, or it could be a system on Azure, or it could be a VM on AWS. It just, as long as it has DevOps has an access, that's good enough. So there are two ways to do it, though. I mean, like DevOps comes with one. The default one is always Azure hosted agent. So which is a Linux, I believe it's a Linux agent. And when we run the pipeline, I mean, like by default, it will pick up Azure hosted agent. But that is what that does is, I mean, like your code, it doesn't have the Terraform code, right, as application code or anything. You are basically running the code build in a cloud environment that is provided by a Microsoft, and which could be, I mean, like it's not specific to our own organization. I mean, like it could be used by multiple organizations throughout the world. So that is it's a publicly available hosted agent. It does support like parallel jobs. So based on the load, it works. It handles the queue of jobs on the hosted agent. The biggest drawback is, I mean, like multiple organizations will be using it. So the other best way is like using the hosted agent. Hosted agent allows us to set up a system within our organization. Again, as I said, it could be our system, or it can be a VM in Azure in our organization network, or on AWS or something like that. So, and hosted agent can be set up on Windows or Mac or Linux. And it's very simple. I mean, once we go here, I mean, again, back in the project, settings, you go to the agent pool. In here, you see, I mean, this Azure Pipelines is default, always comes in, and that's what I'm going to use. Angesh, when he's going to demo, he's going to show you the hosted agent way, because uh, so we are trying to show it in both ways, right? The way we can create is, I mean, like I can just go and click on the agents. I did created one for a Mac, but let me show you. Oh, sorry. I want to do a self-hosted new agent pool. Create and lunch and learn. So I go ahead and click on the agents here. When I click on the new agent, it will give me an option and with the steps what we need to do, because it highlighted the Mac OS, because I'm on Mac OS, it highlighted, but if you're on Windows, it will highlight the Windows. Depending upon the system where you are, it gives you the instructions on how to set up your system as an agent. So this could be, I mean, like done on, as I said, I mean, like we can just easily go ahead and create a VM on Azure and just follow these instructions on the VM to make it as an agent, and just use that agent for all your builds and deploying those kind of things. So it definitely helps, because one thing is, I mean, like it's a dedicated hosted for our own organization. We don't need to depend on like having the agent queue like free at the time when we are running it. And also it's safe for if you're doing any like a safe if you have any like a security concerns or anything, right? I mean, just so that's a advantage of having a hosted agent. So and then definitely we need the repository. I mean, like have the code in GitHub or Bitbucket or anywhere. It doesn't matter, because Azure DevOps can connect to all kinds of repositories online. So that's the initial setup when we're working from Azure DevOps and Terraform, deploying to AWS or Azure. So let me go back again. And some of the things, since we are working on the Terraform now, just wanted to give us a little bit of basic steps, information on the Terraform, how it works on the background. So mainly, I mean, like once we're done with the code and everything, right, the basic steps, I mean, like you can run Terraform as a command line on the system, on our on our own system, or we can run it on the Azure CLI or AWS CLI, or it can be run in the pipelines. But whichever way we do, there are only like the 4 steps are executed in particular order for Terraform to deploy the infrastructure. The first thing is always the initialize init. So what it does is it basically initializes a working directory containing Terraform configuration files. So so just for an example, when we talked about the agent pool, right? So when the agent pool is set up, the first step it does is executes the init, downloads all the Terraform configuration files, and sets up the directory or sets up the agent pool system to be ready for it to work for to plan and apply the Terraform code. So that's always the first one we do it, and it's again the same thing. I mean, if you're working on our own system, just type like Terraform in it, and it will set up everything. Then the next one is plan. What plan does is it goes and checks out the code, and basically does it. I mean, like it looks for the syntax errors or any configuration changes or anything like that. It makes sure everything is fine before we start applying the code, applying the changes to the infrastructure, right? So it's just like a check kind of thing, and it prepares everything for next stage as well. The third part is apply, and this is where all the magic happens. Once the plan is successful, Terraform gets to the next step is apply. It does exactly most of the things just like plan, but the difference is it goes ahead and apply all the changes uh, on the target, like on the destination, right? I mean, so in this case, we'll be deploying some core resources to the AWS or Azure. So that's what the apply will do. And there's a fourth one, which is an optional step, destroy. It's handy whenever I mean, like if you're doing a test kind of thing, or if you really want to like if you want to, we think like, hey, we don't need the dev environment anymore, so we need to destroy it. So the fourth step always is, I mean, like we can, after the applies, then we can just add the destroy using the state file that remember, everything is tracked with the Terraform state file. So if it say, we say destroy, I mean, like it goes ahead and destroys everything that has been done, that has been created by Terraform. It won't destroy anything else. It will just destroy everything that has been created by that particular job, and what it says in the Terraform state file. Those are the only resources that gets destroyed. So it's very handy when we are in just a development phase, when we are just working on uh, trying to prove that we are, I mean, uh, just to save on the cost as well, right? I mean, like in the dev environment, if we are creating a virtual machine or anything, and we really don't need that anymore after we are done, we verified it's there, and just then execute the destroy and destroys things, and that way it keeps things clean. So yeah, that's where we start at the Terraform, basic Terraform things, and okay, I'll let English take the word now from here.
Thanks, Rakesh.
Right.
Before you go, Angashwar, I just wanted to see
Yeah.
if there's any questions. Any questions in the, I know that was a lot for the first section. Anybody have any questions? Okay, I think it looks good for the first one.
That's good. I'm just sharing my screen. Let me know if I can see it.
You are all good.
Okay. So thanks, Rakesh. So this is where he left off. I'll be showing exactly again all these steps again, what he has explained on my system as well while going through the demo. So I just wanted to bring out like some differences between Azure and like the Azure DevOps and the different cloud services. As we can see, like some people get confused whether Azure and Azure DevOps are the same thing or the different things. So I just wanted to bring that out as well. So Azure or AWS and GCP are different public cloud computing platforms, and they have everything within them. Like you can have infrastructure as a service, platform as a service, or software as a service. And most of these tools or applications are basically you can do multiple things on, such as analytics, virtual computing, storage, and networking. So that is one of the differences, main differences. And when we have Azure DevOps, we can definitely tell it's basically a DevOps tool for end-to-end deployment or developing an application as well. It consists of multiple things, like where you can store the repositories, like where you can store the code, similar to GitHub repository, where you can push the code or pull the code and everything there. And also we can have multiple people working on the repositories. So that is again a good thing. We can also, with the help of Azure DevOps, we can also build the code and have multiple releases, and we can also build pipelines and set environments and have variables configured and everything. And as we can see that we can have them in multiple environments, like for example, testing environment, acceptance, and production environment. So this just gives us the compatibility and also the advantage of having them deployed in multiple areas before it goes into production. This is the next thing that I would be demoing as well. So basically where we are deploying an AWS infrastructure. For this demo, we just kept it short and we are just deploying EC2 and an S3 bucket. But we can also deploy the entire infrastructure or also build like applications on AWS or on Azure as well. So we are just going to follow simple steps by having the code, maybe the developer may be pushing it into the GitHub repository, and then with a trigger, we can definitely pull it into Azure DevOps. And then by having Terraform installed, as Rakesh mentioned, we can have a Terraform TF state file, which has a history of all the events that goes on within the Terraform state. And then we can also provision various resources, like as I mentioned, like EC2 resources or Amazon. There are multiple resource services that they can, like SNS or Lambda or AWS cloud deploy, code deploy. So these are certain things. And I just wanted to bring about like one more point, that how we are using CloudFormation, which is only for AWS. Terraform can use it for multiple cloud platforms, such as Azure, AWS, as well as GCP, if anything has to be changed in your cloud environment in the future. So now I'll just go to the demo. So for demo purposes, I have my screens ready. So this is again like my GitHub repository. And as I mentioned, like we can put the code here, or we can also send it here. So as Rakesh mentioned, in project settings, we can have multiple things and service connections. So he's had only Azure, but in my case, I also added Azure DevOps and with AWS. And I also had like my Docker container and other things that I can add it to my service connections. He has also mentioned about the pipelines. In my case, I have used not only Azure pipelines, but I have created a self-hosted agent where I'm having it stored on my local system. So there are some advantages as well, where you where we can directly run it on our system rather than hosting it on the Microsoft Azure platform. So in my place, I ran the Azure pipelines through my code as well onto my system. So I'll just give you small things that we are working into as well. So basically, the Azure DevOps board consists of multiple things where you can write user stories, or maybe you can have board sprints, queries, and everything else. But for this demo, we'll be having only the repositories where we have code stored. For example, these are the similar things that I've stored in my GitHub repository, which I could pull it here. And there is Azure pipelines, main TF. This is one of the Terraform files where we are writing, like, for example, in my code, I had certain things like, for example, the environment I wanted to set up, the project, the version number. And also, if in my case, I'm setting up an AWS S3 bucket. So I just gave the name that I wanted to give it, like my bucket and S3 bucket name. And I'm also launching EC2 instances. So for this purpose, I'm only launching one, but definitely we can have more than one EC2 instances being launched as well. So there's the like VPC ID. If anybody is familiar with AWS, then they would definitely know that these are certain things that we require in order to build a AWS or like an infrastructure. So, and there's one more file which has the parameters or the variables that we are passing through each and everything, like the access keys, or maybe the profile, the EC2 AMI, the instance type, the key pairs, and the number of instances. So these are again the mandatory things that we need to pass before launching any instances or doing anything on the AWS platform. We also have the self-hosted agent, as Rakesh mentioned in his slides about the init, plan, apply, and destroy. So we have written the similar steps in our code as well, where we are going over the functionalities like init, plan, AWS, and then applying the same things. So this will help me build my own infrastructure on AWS platform. So we can actually go and see this in details. If it's sometimes difficult to read the code, I can show that. I'll be showing the demo as well.
Hey, can I add a little bit, if you don't mind?
Yeah, sure.
Yeah. So I just want to you guys to just keep a note here. I mean, you see the project here. Basically, everything, most of the code that you can see here is written in just one file, like in a main.tf. Can you highlight the main.tf?
Yeah.
So within the, if you see here, like we are creating a bucket, we are creating some other, like we some other resources that Anish was talking about. Everything is done in main.tf here, but this is one way of doing it. But there's a way of modularizing all this code as well. So the reason we did this way is just wanted to show everything here works in one file. And the one which I'm going to demo, I'll show you how to modularize the same code. Okay, just wanted to bring it up so that you'll compare it when we come back to the other demo. Thanks, Anish.
Yeah, thanks, Rakesh. So these are the things that I just wanted to highlight. And then again, we can, as I mentioned, like in the repositories where you can push the code, and also have branches and everything, which is similar to GitHub repository. And when we go to the pipelines, for this demo, I was just trying to show like the different pipelines that we have created. One is the classic pipeline and also the YAML where we are writing to the code. So we can also have environments. And again, this was again covered in the slides as well, like where we can have environments, releases, and also we can have deployment groups and everything. Azure DevOps also helps us to test plans, and we can also have other artifacts, but that is about the scope for this project, for this demo. So I'll just go in and dive into uh, the YAML file here. So as I mentioned, like we just saw the main TF and everything. So the code basically would help me deploy an AWS infrastructure. So currently we do not have, we just have the state file, and this was again stressed by Rakesh, where he mentioned that the AWS should have the state file, and this is something that we did manually. And I'll be deploying the EC2 instance. Currently we do not have any running EC2 instances. So with the help of this code here, we should be having certain infrastructure ready to and go in AWS. So let me just run. And we can also keep on monitoring this thing. As I mentioned, I'm having a self-hosted agent here. So that means this is running on this pool here. So we can actually monitor it and see what is the status. It's not that every time it will be in greens. There could be errors as well as in red. Sometimes that comes up and pops up where we have to look into the code as well, or maybe to look into what could be the issues there. So after multiple tries, I think we got everything running, working properly here. So yeah, so we can actually see the different things. Like for example, as Rakesh mentioned, the initialization phase, the planning phase, and then applying all the things that we have worked on. So this would help us in having a successful deployment here. But again, we can actually see everything being built here for live monitoring. And also if we go here back, we should be able to see like some instances getting popped up on AWS here as well as on the S3 bucket. So before this, we had only 2. So this is something new that was just created. So again, we can check the tags and make sure like we are working on the right thing and we have everything. As I mentioned, like in the code, we have the project TF, lunch and learn, S3 bucket, the resource type, and my name. So having the code definitely helps us in making sure like we are tracking the same object here. So, and I think we should also be able to see an EC2 instance that should be running right now. So we have used Azure DevOps pipeline in order to have an infrastructure on the AWS platform. So yeah, currently we do not have anything on the EC2, but we can definitely make that happen as well. For example, a site or something on the S3 bucket as well, we can upload some files and other data as well there. So we have a successful proper pipeline created here. And then now I wanted to just make sure like everything is good and then take you all through. This is basically what we did was to go through the YAML files that we have created. When I say YAML file it would be the YAML file self-hosted agent. And there's another way that we can do that is through using classic editor. So this is again where we are not having much on the YAML file, but we definitely are passing all the parameters here in order to get the infrastructure loaded into AWS. Since we already have it, so these are the certain steps that have already been done. But for this demo purposes, these steps will be again just running. And as Rakesh mentioned, like for example, this is like a development, or if you want to just get rid of the entire infrastructure, we can run the destroy step as well, where we will be destroying the entire infrastructure that was created on the AWS cloud platform. So these are some basic parameters like init, provider name, and also the configuration directory. I'm also passing the service connections as we have seen earlier. The service connections that was important was these things that we have given earlier. So we would be doing that as well. And also the state file. This helps us to keep all the details on the state. So that's why Rakesh mentioned like it is not good to manually make any changes. Everything should go through the state file, so that is it maintains a clean record and it keeps a record of all the different things that are going on there. So we have given.
Sorry. Angesh, I just wanted to add a little bit here, if you don't mind.
Yeah, sure.
Yeah. So one thing I just want everyone to keep notice is like even though Angesh is what he did is, I mean, like first he executed a pipeline which was created using the YAML way, and again he now is showing a different way of doing the pipeline, which is a classic way, right? I mean, it's a UI based. So both ways can be done in the DevOps, but definitely YAML is the one which is the way to go forward. But the biggest thing I wanted to point out here is if you like, we have already run the YAML pipeline. It has created the AWS resources, but you might be thinking now you're running a separate pipeline. How is it going to know that it's going to run in the same way, right? So essentially, both pipelines are two different pipelines, but they're same in the background because they both are using the same state file. So, so the thing to remember is, I mean, like pipeline. I mean, the state file is not tied to pipeline, but multiple pipelines can use the same state file. So that's something that need to be careful when if someone is going to work on setting up these pipelines. But this just for the demo purpose, we have two different pipelines. Uh, it's always plausible. Just wanted to explain that a little bit.
Thanks, Rakesh. Yeah, and as I mentioned, like we can definitely see the state file as well, which is on the S3 bucket. Here we have the Terraform state file here. So yeah, we will just run this right now, which is using the classic pipeline. And again, we are using the same pool, that is self-hosted agent, and also the branch and everything is the same. And we can also see here that if anything issues are there, so it definitely came like it succeeded. But if there is any failure or something, we can definitely check it on this place as well. So again, we are running through the same steps, that is initialization, plan, apply, and the last step, that is destroy. So with the last step, we would see that this new bucket that has been created would be destroyed from here, as well as the instance that was running on the EC2 instance would be stopped after once the job is run completely successfully. So again, this is similar to what we have seen in running to the YAML file, but yeah.
Are there any questions at this point? We're hitting about almost 20 minutes left, so I just want to make sure we get any questions in.
So this does take some time sometimes, depending on the things that we are loading there. So before this, I had more heavier infrastructure, which would take more time. So, but for this demo purpose, we just kept small and light things here. So that does not take too much time. So we see that everything is being destroyed right now. So I think once that gets triggered off, this should stop automatically. So this running instance did stop here. And once we go through the S3 bucket also, we should be able to not see that the last bucket and have only two back in place. So the remote, that is the state file, would not be deleted in this case. It's only the new bucket that was created will always be deleted. And we see that this has been run successfully as well without any issues. So yeah, that was the demo from my side. And Rakesh will be taking forward with the demo on having the infrastructure loaded on the Azure platform as well. Thank you.
Thanks, Angesh.
You can share your screen right now.
Yeah. So I'm sorry. I don't know if I'm sharing the screen or not. Are you guys able to see my screen?
Yeah, we can see your screen.
Okay, great. Thank you. So let's look at the. I'm like Angesh has shown us how to deploy to the AWS, right? I mean, like, I'm going to show how we deploy to the Azure. One thing I want to show before we start is I already created a resource group on our account. Sorry, not here. Let's go. I already created a resource group on the Azure side, and also made sure that the app service plan is also deployed because this takes some time. So I went ahead and did it. And everything is deployed through Terraform. Even this resource group has been deployed. And let me show you the code, how it works. So basically, okay, let's go in the main.tf. I'm in here. This is the code where when we say Azure RM resource group, this is the one which is creating this particular resource group, right? So but- and you can see here, I mean, like we can tag it, whatever tags we need, the name, location, and everything. So that's good. And then app service plan also, we went ahead and ran it so that it's ready. So let me talk about modules. Remember, I was talking to you when Angesh was talking, he had everything in the main.tf. But what I did is, I mean, like in the Terraform, how we can do it is we can modularize the resources as well. So for that, I created a modules directory, and within module directory, I mean, like I was able to go ahead and separate out each type of resource instead of putting everything in one code. I mean, like it's just like a regular programming. I mean, just deploy, write code in different area. And even in here, we can, most of the times how we work is you always have a main.tf, which does your big workload. And then output, once we get done with the with the like a provisioning resource, then output can be sent so that it can be used by other resources, and then the variables basically that it expects when we come in to do some of the stuff. So that's how the general layout of the Terraform works. And the way in the background it works is like why we have modules here. When Terraform runs in the background, it looks for all only like .tf files. TF files, I mean, like you'll see like multiple TF files. One is local, main, provider, variables. In theory, all this can be put into one file. Doesn't matter. It doesn't matter for Terraform. So if you have 100 .tf files, it will combine all of that and make into one big file for it to work with. But for us, readability purpose, it's always good to keep them variables separate. These are the variables that basically, when we run the pipeline, we are expecting these variables to be provided either through or manually or through the code or something. But here, all these variables, when we're coming in, I'm providing it through the file called .tfvars. So this is another file type that Terraform supports. Within this, we can provide all the information because this is just a lunch and learn. I went ahead and typed everything, but there's a ways for us to you get these values from the key vault or some other secure place as well. But yes, so the variables that we have here, all the values are typed into the TFVars, and then the provider. This is one of the main thing that tells Terraform what provider to run. Definitely, it requires a Terraform version that we need to use. And then the Terraform backend, Azure RM, right? The Azure RM tells, okay, I want to run this on Azure. Similarly, if it's AWS, it has a AWS provider, separate provider. So based on the provider, Terraform knows on which platform it's going to work on. So, and some of the features we can define here. And there's four different types of declarations we can do. One is variable. Variable is always with saying like variable resource group name. Output, as I've showed you, output is basically defined as an output. And there's a locals called locals. Basically, it's a local variable that is used within your local area. So when I'm working here, this local will be used only in this directory. If I'm going to go and execute app service, it won't know. So for that to work, in the main, so again, I mean, like everything starts from the main, right? Most of the time we call it main. So in here, if you see, Terraform already knows what provider it is. Now that it comes to the main TF, it creates a resource group. If it doesn't, if the resource group is already there, it will just ignore that. And once we are done that, I mean, like if you see the app service plan, when I did the modular, so what I did is created the call source. Basically, I'm saying the source is in this directory in the modules app service plan, which is over here. But for to execute that app service plan requires these variables: resource group, app service plan name, location, environment, and default tags. And these I can transfer from the variables. So which basically, if you can see, all the variables are defined here again. And what it does is it goes ahead and executes this the code in the app service plan, what it needs to do. So this one is picking up the variables from here. And one thing you need to see is, I mean, how it works is resource group is the first one to create, so it is not dependent on anything. But app service plan is dependent on resource group here. So in order to make this module dependent on Azure on resource group, we basically reference that this module, this block of code here. So when we can directly type the name of the resource group here, but what does that is, I mean, that expects the resource group already exists. But referencing a resource group here, it will make sure that app service plan waits until resource group is been provisioned. So once the resource group is provisioned, then app service plan will go ahead. So since we already have it, I just want to go ahead and show you. And again, this TF-vars, when we provided the variables, this TF-vars is referenced here in the pipeline. If you look at this, I'm saying system default directory, which is a default directory, and learn.tf-vars. And I use this reference only in the plan and apply. So plan also makes sure that everything is good, applies it. So that's how we pass in the variables in here. Just want to show, yeah, okay. Let me go ahead and make an edit here. We'll go ahead and deploy app service. You know what, I'm going to go ahead and deploy the key vault as well. So I uncommented the code where we'll be deploying. We already have the resource group deployed. App service plan is deployed. Now we're going to deploy app service, application insight, and key vault. So one thing I want to highlight here is app service ID. When I'm creating a key vault, I want, so most of the times we need the app service to have an access to the key vault. So basically what we're doing is we're giving the app service ID as well to the key vault, saying, hey, I need the get and list access to the app service on key vault. So the way we are sending the app service ID is, again, say module.app service principal ID. So basically, when we do this, it is going to wait for the app service to be deployed first. Once they're deployed, then it will get the ID, pass it on the key vault. I'm just going to comment it here. I'm sorry, I'm running a little fast because we're running out of the time. But if we go to the key vault here in the main.tf, once it comes to create the key vault, you'll see we have a code here saying application access. So while creating the key vault, we are also giving the access to the application as well. So within here, saying since the key application ID is been passed in, we're saying we need the get list permission. So that's all it's doing. So let's go ahead and run the pipeline here so we already have a pipeline. I mean, the YAML that I showed you. One easy tip here, if you don't know how to write YAML, no problem. A lot of the times what happens is we can basically search for any task that we are working for. You can click on the Terraform. Right now, because we are doing Terraform, just give some values here and you click and add, it will add the YAML code right here. So that is one way to do YAML coding if you're new to it. So So let's go ahead and run it. I'm just going to discard that because we already have a pipeline. And remember, what we did is in the main.tf, we uncommented the app service, application insight, and keyword. And if you go here, refresh, we have only app service plan. Now, after the thing is run, we'll see three more resources over there. So I'm just going and running, and this one is using the hosted agent on Azure, public one. So unlike what Angesh did, which he basically hosted the agent on his system. And there's some separate steps. I mean, like replace tokens and everything. I mean, like I'm just replacing the tokens. Again, that's not as a Terraform thing. It's you can use. Oh, no, I might have missed something here. Just a second. Yep. Forgot to remove that. Sorry.
It wouldn't be live coding without something breaking at least once.
It's always, I mean, like a. So yeah, while it's running, we'll come back. I mean, you can see it's going to run, and I will show you how the key vault, the app service will have access on the key vault. Meanwhile, this is running. I mean, do you have any questions on what I kind of explained on the Terraform?
Yeah, anybody have any questions, feel free to throw them in chat, which is in the lower right-hand corner, and I can ask them for you. If you're in a loud place, get pets, dogs, kids, feel free to throw it in there. Or if you want, raise your hand towards the bottom, and I'll go ahead and call on you.
And I just wanted to highlight one thing, what I did in the locals.tf, if you can see here. So for each resource that we're deploying, we need to, I mean, like it's always good to have tags, right? I mean, like what organization it is, belongs to, or anything like that. So one of the things I'm doing here is I'm kind of like versioning my infrastructure, saying, hey, I'm like deploying right now 1.1. If the next time I'm going to deploy in a production, I'm going to call it 1.1 or something. That way it will tell me if my code and my resource match together, right? So what it does is when I set the default tags here, I'm applying the same tags to each and every resource that we are setting up. But at the same time, we can always have extra tags as well, additional tags as well. So that would be an example here. So what I'm doing is, if I'm the app service, I'm saying, hey, I'm here. I'm going to use the default tag that has been defined in the locals.tf here. But also I need an additional tag saying my resource type is app service. This cannot be applied to other resources, right? So each service can have a separate resource. So I'm going to, basically what I can do is merge the tags with the additional ones. So I'll show you once it's done. So it's still applying. Will take a minute and it should be done. Because it's doing key vault, so it might take a second. So that's the advantage of like applying default tags. And again, if since it's an app service, some of the things, application insight, like a lot of things. More, I mean, like we tend to go ahead and do it manually, but everything that can be done manually can be done through the code. And it's always good, right? I mean, like as a developer, if you think, hey, I need to add the Docker information here, right? You will know what it is. Just go ahead and enter it. It will take care, or some other property. You need to change the port number. Just change the port number, run the pipeline, and it will update the resources on Azure side. So it's just taking a little extra time. I'm sorry about that. Any questions at this point?
Rakesh, so what would you say was your, what was some of the, when you were getting into this for the first time, what would you say was your best resource for figuring out?
My best resource, I would say, just self-learning. Like there's a lot of documentation online for, especially look at the Terraform. Like Terraform has a very good documentation on their site. If you go there, the documentation's over here. And as the same way, Azure has their own, AWS has their own documentation. But if you want to learn in a sequential, like you want to really learn everything, how things are working, I would definitely recommend Pluralsight or Udemy. They have like a lot of good courses over there, which can help you run through this things. Also, like Microsoft, the advantage with the AWS, GCP, or Azure is if you do not have an account with them, you can always have like a 12 months free account. There are a lot of resources that can be deployed for free of cost. You just need to be careful though, because sometimes accidentally you might provision some resource which will cost a lot of money. So, but 12 months you get the to work on the Azure or AWS. That would be a good thing to do. I'll always, like if you don't have an access to Azure. So.
For sure.
Okay, and let's see. So my pipeline is run. It's all successful. As I said, it does initial plan apply, so everything went fine. Let's go ahead and refresh my resource group here. Now you can see the app service plan was already there. There's an app inside created, keyword created, and app service got it created, right? We can go ahead and check the app service, look at the configuration. Just want to show you some code here, because in the app service, we had this configuration here, the app setting configuration are there, right? So all those app configuration are here. Similarly, if we go to the keyword now, remember I told you about the keyword. We had part of the thing was to provide the access to the app service, which is this app service. Access to the keyword with the get and list permission. So let's see if it has created or not. We go to the access policies, and you can see two policies here. One is for the DevOps, which is part of keyword. So there are two policies we are setting. One is access policy for our DevOps environment. So basically for this DevOps to be able to create and read and everything. The other one is for the application. So the second one is application. If you see here, it says SDS orders lunch and learn API. So that was the app service also we deployed. And it has two permissions, get list. So that's how, that's how easy it is. Like anything that we need to change, we need more permission that on access on the keyword. All we have to do is go ahead and add more permissions over here, and then run the pipeline. That will take care of it. So that's how we do it. And I think that's all I have to show.
With 3 minutes to spare, any questions? I know we're getting close to time. People might be needing to run to meetings next. Any questions? Going once. Going twice. Sold. Well, thank you everybody so much for coming. If you run into a question or you wouldn't want to ask a question in front of the group, please hit me up afterwards. You can find me on LinkedIn, as well as my email is katie.endo@smartdata.net. You can ask there, and I can put you in contact with Rakesh and Angashwar, and we can get you the question answered. So thanks everybody, and have a great day.
Thanks everyone.
Thank you.
Thank you.
Thank you.